Oh boy, that guy's got some problems. He doesn't know much about algebra. Well, we're going to make sure that you all know lots. All right, welcome to the Johnson Kendro Video Hour.
But it's not an hour.
Someday it just might be. All right, today is 4-4, factoring quadratic expressions. All right, factoring. Our definition of factoring is rewriting an expression as a product, which is when you multiply, of its factors. Well, what are factors? Oh, those are things you can multiply together to get an answer. Like 2 times 5 are the factors of 10.
So that's all we're doing today, factoring numbers?
Well, no, we're going to factor quadratics. So it makes it a little more complicating, but you guys have foiled before. We got to realize that factoring and foiling are opposites. Okay? So when you foil something, you do first, outside, inside, last. So our firsts are x times x. Our outside, negative 3x. That's x and negative 3. Then our inside is plus 2. And our last is negative 6. Together, if I put these two together, I get negative x minus 6. All right, let's look at the next thing. Now, you need to notice that this x squared minus x minus 6 is exactly what we got before. So today, when you do problems, your answer is going to be the parentheses form. Okay? So the x squared gets broken into the x and x. The negative 6 gets broken into the 3 and 2. And then the plus and minus signs, we'll figure those out. But for ours right now, it's minus 3 and plus 2.
So we're unfoiling.
We are unfoiling. All right, another step that you have to be aware of is to look for, look for a number or letter that you can divide every term by, and then you're going to undistribute that number or letter. So you're going to take it out front to kind of get it out of the way so that you can deal with the rest, either factor or otherwise. So I notice that I have an x in each of these. So I'm going to take that out front, and x times x gave me the x squared, and then I need a minus 3. Think of redistributing that, and you should get back the original problem.
So it's kind of like you're dividing, huh?
Yeah, you divide out that x, but you have to leave it out front. All right, the next one, I still have an x in common, and I take that x out front, divide it out front, and I have left 2x because those two have to make this, and then I have a plus 5. Okay, the next one, I have numbers and letters. The numbers we do first because this is math and not English. So we take a 2 out of each of those, and then I have an x in common for each of those. So I take that out front. Now what I need to multiply 2x by to get this is an 8 and another x.
There's nothing left in the second one, is there?
Oh my, but I need something because I took it out. I divided 2x by the 2x I brought out front. So dividing it by itself will leave me with 1. You got to remember, you must be able to distribute that 2x back in to get both of these.
All right, those were some binomials. That was taking out a greatest common factor. And sometimes you have to do that with trinomials too, but definitely with binomials on your assignment. So I'm going to go through the steps for factoring trinomials. We're going to spend 2 days in this lesson. In today's lesson, all of your a values are going to be 1. So that means your polynomials are just going to start with x squared. And these are the steps that apply if your a is 1. I'm going to uncover them, and you guys can hit pause and copy them on down because they're long.
Welcome back from that pause.
Okay, so let's go through our examples. First one, so we have x squared minus 2x minus 8. You look for a greatest common factor. A lot of times there isn't one, but you always want to look because it might make your life easier if you can take that out. So the next thing I want to do is draw my 2 sets of parentheses. I want to fill in the signs. So C is key.
C is key.
C is key because you're going to look at that C. It is a negative C value. For us to multiply to get a negative, the only way for that to happen is to have one positive and one negative. And it doesn't matter if you put the plus first or the minus second, or vice versa, as long as you get your one of each filled in. We're going to put the numbers in there later. Also, we know that it's x squared. And to come up with that x squared, you do the first times the first. And the only way to make that happen is an x and an x. And tomorrow it's going to be different. There's going to be numbers out in front. So now we're on to the last part. We need to just factor our c value. And the cool part about taking care of the signs is you can just factor the 8. You don't need to worry about the minus. So Mrs. Kendra, what are things that could multiply to get 8?
1 times 8.
1 times 8?
Do I have to say 8 times 1?
No, you do not.
Okay, cool. 2 times 4.
2 times 4. Are there any others?
Not that are whole numbers.
You know what I really like is that you went in numerical order. You did the 1, and then you did the 2. 3 doesn't work. The next number technically would be 4, but then we'd be back to 4 times 2. And when you get there, then you know you've got all the factors.
All right.
And sometimes, if you can find them without the list, then good for you. But sometimes we need the list. Okay, so from the list, I'm looking for numbers that add or subtract to get me the b value. And remember, one of them is positive and one of them is negative. So if you were to add together with 1 and 8, I don't think that's going to work. So I think that we want 2 and 4. Now the hard part is to decide which goes with the plus and which goes with the minus. We want to add to get negative 2, so the bigger number is going to have to go with the negative.
Because negative 4 and plus 2 is our middle term negative 2.
That's right.
All right.
The last thing we had in our steps, it did say mentally FOIL to check, and you don't have to do that every time. But the nice thing about factoring is if you were to FOIL that, x times x, that's x squared. X times negative 4, negative 4x. 2 times x, 2x. And last times last is minus 8. Really, you're checking these middle two things. Make sure you come up with that b term. So again, that's optional. But who doesn't want to know they got their answers right?
I know, I do.
All right, let's do another one. Okay, no GCF. We're ready to draw the parentheses. This time you're going to look at your C, and I see that the C is a positive. So when you have that, your options are a positive times a positive or a negative times a negative. And the way that we're going to decide is by looking back at the B term. That's plus, so it's got to be a plus and a plus. All right, then again, x squared, the only way for us to get that is x and x. I want factors of 24.
Wow, there's lots. How about 1 times 24?
Okay.
2 times 12. 3 times 8. 4 times 6. Wow, there's lots. There's no 5. And then I'm back to 6.
So that means we're done.
Yeah, I already have my 6.
So I see it, I think. Is it 2 and 12?
Ooh, I don't know, because if you add those, you get...
But if I did 12 minus 2, that's 10.
Yeah, but look at our 2 plus signs. They have to all be plus.
Oh, okay. So that means that's not going to work. So that doesn't work. I don't think that works. That's 11.
Yahoo!
So I think we want 4 and 6.
You betcha.
And then again, you can mentally FOIL to check. I was wondering, would this be correct?
Well, heck yeah, that displays our commutative property of multiplication.
So the order doesn't matter as long as you got your signs with the right stuff.
We got the right stuff.
Of course we do. All right. Doing another one. Drawing our parentheses. This time, C is key. C is
key.
Plus. So options are plus plus or minus minus. And we look back here. That's going to determine what we need. Factors of 6 are 1 and 6 or
2 and 3.
2 and 3. Okay, I want with them both being negative to add up to get negative 7.
Gotta be the 1 and 6.
Gotta be the 1 and the 6. Nice job.
Thanks.
You're getting pretty good at this.
I think these are fun.
Me too.
Factoring is fun.
All right, next. I've got a minus. So again,
Ooh, that means one of each.
That's right. The only way to multiply to get a negative is a positive and a negative. Got to be an x and an x. Factors of 8. Kendra, go.
1, 8, 2, 4. That's it.
I don't see any things on this list.
Oh my gosh. 1 and 8 does not add or subtract to get 3. 2 and 4 does not add or subtract to get 3.
Okay, so here's what happens when you see this. Make sure you wrote down the problem correctly.
Yeah, first step.
Yeah, I think we did. Make sure we list it all, make sure we got our signs correct. If you do all of that correctly and you cannot get anything to fit, that's because this is called a prime polynomial. It's a prime, it's unfactorable.
It's a prime example of being prime.
That's right.
Very good. So we just leave it.
Yeah.
Just say prime. We don't have to do anything else.
So you can't factor it.
Oh.
Okay, last one like this. Oh, wait a minute.
Ooh.
I'm a little afraid because there's this number out in front, and I thought that we weren't going to do any of those today. But if you look, all of those numbers are divisible by 5. So that's the greatest common factor. So you want to start by taking out that 5. So divide each term by 5. We'll get x squared, 10x, and 16. So I'm done, right?
No.
Okay.
Now we're just back to the same deal, but with a 5 sitting out front.
Yeah, 5's just going to come along for the ride every time. X and x plus, plus, plus. Because when you have a plus, your options are plus, plus, or minus, minus, and you look back to B to tell you which one to choose. I need factors of 16. Kendra, go.
1, 16, 2, 8, 4, 4.
Ooh, that means we're done.
Yeah, because we got the 4 twice.
Okay, and I need things that add up to get 10. I think we're choosing our 2 and our 8. And make sure you include that 5 in your final answer. That's an 8.
All right, very cool.
Okay. We are going to cover one of the special cases today. It's called the difference of squares. This is going to look a little different. It comes in the form a squared plus b squared.
Minus.
A squared minus b squared, and that's important. It has to be a minus because it's a difference of perfect squares. So these might be variables that are squared, they might be numbers that are squared, but that's how you're going to recognize them. So I see that it's a binomial, meaning 2 terms, and there's subtraction in between. And what that means is it's going to factor into this form, and we're going to use that in a second.
So it's always going to be plus and a minus?
Always a plus and a minus, and if you notice, the numbers in the first place are going to be exactly the same, and the numbers or letters, whatever we're working with, are going to be exactly the same in the second spots.
Seems kind of easy.
I hope so, but I do have one little hint for you that you can also use, and let me show you how to do that on our first example. Okay, so it is a difference of squares, and you could follow the formula, but here's something else that you could do. You could just notice that there is no x term in the middle, so you could rewrite this equation with a 0x in the middle. And then the cool thing about that is you can use the same steps that we've been doing. It would be x and x. This is a minus, so 1 is plus and 1 is minus. And when you make your list, you're going to look for factors of 64, but they have to cancel. They have to get 0.
Oh.
So the only way is with an 8 and an 8.
Aha.
The little quicker way is just to notice that the square root of x squared is x, and the square root of 64 is 8. So they're both x and 8, and then the signs are just different. So this is our final answer.
Okay, so you just square root each, but one's a plus, one's a minus.
Yeah. All right. Now this one has a number in front.
But it's a square.
But it is a square, and it's got to be a perfect square for this to work. So again, we want to square root that first term. So what do we get when we square root 4x squared?
2x.
So that means in the first places, we get 2x and 2x. Now remember, it's got to be a minus for this to work. That's what makes this a plus and a minus. Next, we're going to square root that 49.
7.
7, 7.
Woo.
And they should be exactly the same.
That's pretty fast. There's not a lot of thinking in that.
That's right, but the hard part is to recognize
Right.
that it is one of those. All right, I know this one is going to be 3x plus y and 3x minus y, right?
Oh, I don't know.
I don't know either.
Uh-oh.
This is not a difference of squares. Okay, that's got an
It's a
addition
sum
sign.
of squares. It's not a difference.
So that means that this little special case does not work for this situation. In fact, maybe you could take out a greatest common factor, but I don't think that those two things share any factors. So this is going to be a prime polynomial again.
All right.
Not factorable.
Cool.
All right.
Well, we are in our prime. We will see you tomorrow, and you'll be in prime form to do well on factoring. Ta-ta for now.